This is what I want to cover today, and this is going to be the last of the React stuff. Frank is going to take over the show next week, and he's going to start looking at the web API side or the server side, as well as maybe some generic, I suppose you could call them just web issues really, rather than JavaScript. I think he's going to look at promises and async await and some other topics as well that would impact both on client side and server side. So anyway, today, usual story now, we're going to have the last part of the movies fan app today. And so you now have after completing this lab, you'll have the foundation for assignment 1 if you're opting to go down the movies app route. And by the way, now if you're going a different route, then you need to let us know what you're planning so that we can give it the okay. So here are the slides, and a lot of what I'm doing today is trying to maybe improve some design aspects and performance aspects and user experience aspects of a React app, and we'll see them being applied in this week's lab as well. So I'm constantly trying to keep the lectures aligned with the labs, which makes sense, I think. So anyway, we're going to go back to patterns. There's one other pattern that I need to look at. It's a pattern that I haven't mentioned at all so far, but as it turns out, it's a pattern that pretty much every React app of any significant size is more than likely going to want to use, called the provider pattern. I also want to look at the whole area of communication between the client and the server. And as we know, what the client, i.e. the React app, uses the server for is mainly to fetch data from the server. But can we improve that aspect of our React app? And by improve, I mean improve the performance of the app. And by improving the performance of the app, we improve the user's experience. There isn't any unnecessary kind of delays in updating a page, that kind of idea. And the last topic, we're going to go back to routing, and we're going to look at the final of the routing samples, which, as it turns out, all the final sample does is implement good old authentication, log in, log out. Now, that may seem like a trivial thing to want to do at the very end of all of the stuff that we've covered on React. But as it turns out, the implementation of it involves using a lot of the aspects that we've looked at up to now. So we couldn't really have discussed it until we had all the kind of preceding stuff covered. And it's tricky enough kind of implementation, as it turns out. So patterns is the first thing I want to go back to. And I want to talk about the provider pattern. Now, that name, the provider pattern, is a general patterns name, but how it relates to React. React has this construct called a context. And so that's what we're talking about in the context of React. But what a React context is an implementation of this provider pattern. And so when would we need to use the provider pattern? And it's simple enough, really. It's whenever you've got some data that you want to share across a number of components, what we might refer to as global data. Now, we never like global data in general when we talk about programming, but when we've got a React app that's made up of lots of components, then there will always be the case where there is some data, usually data, nearly always data that comes from the web API, which a number of components need to know about. So where do we put that data is the question, and the provider pattern gives us a solution to that. The other thing that the provider pattern helps us to avoid is something called prop drilling. And they're interrelated, really. These two are interrelated. So Here's a diagram that I picked up on the web. I wasn't mad about it because it had all these little emojis stuck into it, which I don't like, but it gets the message anyway. So what I'm trying to get across here is, let's suppose we've got this stateful component at the top of my, or very high up anyway, in my component hierarchy. It's stateful, so it has some data. We don't know what the source of it is, but as I say, it's usually data maybe that has been retrieved from the web API, but it's data anyway, and it's data that a number of components need to know about. In the context of this image, it looks like this component way down here needs to know about some of the data in that state, and this one here needs to know about some of it, and this one here needs to know about it. So, you know, maybe they render some part of the state that's actually being, that's located up here. So how do we get that data down to those subordinate components? Well, one solution is to just pass them down as props. So that would mean that this component would have to pass props to this one. This component doesn't use those props, but it just passes them on, and eventually it arrives down here. So all of these intermediate components, they are playing, the only role they're playing is as intermediaries. They're just taking props and passing them on. They're not using them. That's what we call prop drilling. And it's not a really nice kind of solution, you know. Same goes on over here. So what the provider pattern does is it gives us a solution to that. Equally though, it may not actually be data. It could be actually behavior as well. So maybe there's a function up here, and it's this component down here that really needs to know about the function because it wants to execute it or trigger its execution. But maybe it's best to just think about this provider pattern in the context of data. Stateful component has some data, and there are components down the hierarchy that need to know about some or all of that state. Okay, so that's the problem we want to solve on the previous slide. And how do we do it then in React? The answer is we implement provider pattern, but that doesn't really tell us anything. So here are the kind of the aspects of our solution to this implementation of a provider pattern. And it's going to go back to components. I'm saying number one, we need to declare a component for managing that shared state. So the shared data or the shared state is that state in the very top component from the previous slide. And we simply call that component the provider component. And it's going to manage the state in the same old way. It's going to use the use state hook and maybe the use effect hook if the data originates from the backend. So we know how to implement all of that. There's nothing particularly new in that in step one. Step two, I'm saying that we need to create something called a context construct, and React will allow us to do that. And we need to associate that context construct with the provider component. Step three says, now place all of the shared data into the context. So this context construct, that's where we are putting the data, if you like, the state that we want to have available to other components. And step four then is we need to compose. So React is all about component composition. We need to compose the provider component with the other components that need to access the data. The other components we refer to as consumers. So we need to compose the provider with the consumers. Now the part of this jigsaw that we don't know anything about is this thing called a context. So what I'm telling you here, I'm elaborating on what I mean by a context. So it's okay, it's the glue for this whole provider pattern. And what the context is, I'm saying is it wraps, or what we use it for is it wraps the data, I'm saying, and behavior as well, because if there is some piece, some function declared in your provider component, and we want to make that function accessible to consumers, then that's why I'm saying and behavior here. But either way, we wrap the data that we want shared, or the behavior, inside this context construct. And by doing so, we're actually going to avoid prop drilling. but we need to see how really, or how do we actually achieve that. And then the provider, the product component manages the context. Okay. So it's all a bit woolly so far. The consumers access, they need to access the context in some way. And it turns out that there's going to be a hook that will allow us to do that, a special hook that allows us to access the context. So the kind of steps are you create your provider component, you implement your provider component that manages the state using the use state and use effect hooks. The provider also creates this context construct. It somehow puts the data that it wants shared into that context construct. We compose the provider with the other consumers, and the consumers, in order to access the context construct, it uses a special hook called the use context hook. Here's the actual implementation elements. Or sorry, before I do that, here's my kind of visualization of it. So my orange box there on the top left is my visualization of this context construct. And we can see now that our consumers, somehow they can access it directly. So there's no longer the need to be passing props down along the hierarchy. But that's just a visualization. Here's the actual implementation. So the first thing we said we need to do is implement your provider component. That's just a component that manages the state. So it's just an ordinary component at one level. So I've called it context provider, but it's my provider component. It has some use state and use effect hooks in there in order to grab the data. Let's stick with the data aspect of this rather than behavior. But it has the shared data now inside in some sort of state variable. Now, a very important line not to miss is this line up here. This is how we actually create a context. So it's just a method associated with the React framework called create context, and that creates this context construct, which admittedly is a bit abstract, but you can think of it as my orange box in the previous slide. Now, the other thing that's slightly ugly about the implementation is what's going on here. So in my provider pattern, what you need to do is, you see the context actually doubles up as a component as well, which is not a great implementation, but there you go. So this context construct, it has kind of two roles. It's a component and it's this context wrapper. So what I'm doing here is, what we need to do here is you can take this as kind of boilerplate code. You just go whatever the context name is .provider. And so we're using context now as a kind of a component, and the context component has a prop called the value prop. And in the value prop, you assign it an object, a set of key value pairs. Now it's the key value pairs that you put in here. That is how you put stuff into the context, into my orange box. And typically the key value pairs here, the key can be whatever you want them to be. The values would be the various aspects of the state that you want to have shared across other components or with other components. Also, the key, the value might be a function that you've actually declared inside here, and you want to make that function available to other components. So it's important now to remember that this value prop, you assign it an object, and the key value pairs in that object, they are the things that you are making accessible to the consumers. So that's that. And you notice also that I'm actually doing composition here. I'm doing props.children, and we know that's how so that tells us we are going to be composing this component here with other components. That's the composition part. Here is, okay, here's the other part of that composition. So this provider component that I've created on the previous slide, you nearly always compose it with the rest of the entire app. Now, this app component here, the assumption here is that this is where we're going to have all our routing logic. And you can see here, I'm using the browser router. And the component that has the routing logic, that is always the component at the very top of your hierarchy. And that's where you will see your context provider. This is my provider component. You see it being used as mixed into your routing configuration. And of course, by putting it here, that means everything that's inside here is now being composed with the provider. So in fact, we're composing the provider component with all of the rest of the app, all of the other components. You can't be kind of selective as to what you want to compose it with, but that's okay. So that's the composition part. Next, we turn our attention to the consumer components. And I've got an excerpt here from a consumer. So what the consumer needs to do is, number one, it needs to import the context. Now, on the right here, just for convenience, I'm repeating the provider component that we had a few slides back. And I'm just highlighting the fact that what you're importing here is not the provider component. What you're importing is the context that was created within the provider's code base. So we're importing that. Here we're using the use context hook. And so that is now, that kind of completes the ability of the consumer to see the context, to see the orange box, if you like. And again, to help you understand this variable here, if you think of this variable, it's essentially a pointer to the object that you assigned to the values prop over here. And so if that's the case, if this variable here, and call it anything you want to, if that's essentially a reference to the object that you've created here, that means that my consumer can now see and index into the orange box in my visualization from a few slides back. And so, for example, I'm saying if you do context.key here, anywhere within the code here, what this context.key is going to be referring to is one of the values that you have over here. Hence, it can access the shared data that's stored inside in the context, or my orange box. So they're the pieces of the jigsaw. It's a little bit fragmented, but once you've implemented this once, really, you can get the hang of it. And what you will notice is that in a lot of third-party libraries that you use, and there's another third party that we will use a little bit later on in this lecture, a lot of them avail of this provider pattern stroke React context construct to facilitate whatever the third-party library is implementing. So as well as having our own custom providers, a lot of third-party libraries also provide providers or contexts as part of their implementation. It's also from a design point of view, from a separation of concerns point of view, is that if there is a lot of shared data that you want to make available to your consumer components, then rather than kind of stuffing all of that data into one context or into one provider, it's better from a design point of view to break it up into multiple providers. And so all I'm showing you here is that it's perfectly okay to have lots of providers appearing in your, as part of your routing configuration, if you like. In many cases, it doesn't matter the order in which you put these, but in some cases it might be, because it's quite possible that this provider here needs to access some data that's made available by this provider here. And if that is the case, then this has to appear nested within this one. In other words, it has to be a child of this one. It doesn't have to be a direct child, but it has to be a child at some stage. So for very large applications, you may actually have a number of implementations of the provider pattern, custom provider patterns for the data that you want to have shared across multiple consumers, shared with multiple consumers. And you see me using this provider pattern in this week's lab, because where it turns out, where it becomes useful in the Movies app is our list of favorites. We have 2 pages that need to know about the list of favorites that the user has selected. At the moment, what we're doing is we're storing those favorites inside in the browser's local storage. That's okay, but it's not a nice solution. What we'll do in this week's lab is we'll actually put the favorites inside in a context provider and then make it accessible to whatever page needs to know about it. I'm only including this slide here just for completeness. It certainly isn't going to impact on any React development that you'll do for me, but if you're doing React development down the line, something to be aware of. It turns out that using this context idea may not be the best solution for all instances of shared data. For example, if by using a context, all you're avoiding is what I'm calling shallow prop drilling. In other words, well, the opposite of shallow is obviously deep prop drilling. Deep prop drilling is where you're passing the shared data down through multiple layers in your component hierarchy. Shallow prop drilling is where you're passing shared data, maybe just down 1 or 2 layers in your component hierarchy. And if you're only passing the shared data down 2 layers or less, then just pass them as props. Just use prop drilling, because that's actually going to perform, your app is going to perform better using prop drilling rather than using the context approach. Now, admittedly, I think I probably break that rule in the Movies app because I just wanted to have some example of using context in the case of the Movies app, but in real life, it may not have been the best solution. Number 2, if the nature of the state that you're sharing is very volatile, it changes very frequently during the runtime of the app within the browser, then it's not a good idea to put that type of state into a context, because every time the state changes, the context provider component, it needs to go through a re-rendering, and that context provider component is at the very top of our component hierarchy. So that means every time the provider re-renders, every single component in the hierarchy potentially goes through a re-rendering process, and that's not a good idea. So if the state is changes very frequently, then think twice about putting that kind of state into a context. And the third thing is, if the nature of the objects that you're putting into the context are very large, then you might need to think twice as well about doing that. So I'm only, as I said, I'm only including these here just for completeness sake. I'm not going to be analyzing whether you've used context correctly or not. So that's the provider pattern. And you see it in use this week, and hopefully it'll just make a whole lot of sense to you once you've gone through one iteration of using it. Switching on to another topic, data fetching. And with this, really what I want to talk about is this notion of caching data. The data in this case now is data that you are fetching from the back end. If we take a step back, so a single page app, or a React app in our case, it has 2 types of data typically that it needs to manage internally. One is called client state or client data, also often referred to as just app state or app data. And client state is, examples of it might be the best thing. If you've got some sort of menu selection within some part of your app, and the user selects one of the options in the menu, and that causes the page to change what it displays. Clearly, we need to store what which option in the menu the user selected at any particular point in time. And we would do that inside a state variable using the useState hook. But the menu option that was picked by one user using your app in one browser is going to be very different from another user using the app in a different browser. Similarly, the UI theme, if our app had the ability to allow the user to select the theme for their UI, the value or the option that the user would have selected is really local to that particular instance of the client running within the browser. So client state data tends to be private to a particular instance of your React app. And each instance of your React app running in different browsers, they would have their own values for client state. And they never need to share those values with any other client instance running on another browser. Okay, so that's one characteristic, that's really what we mean by client state data. It's characterized, as I've kind of already alluded to, in that it's client owned, it's private to each instance of your React app. It's not shared across different instances of the app. It's not persisted anywhere. It's certainly not persisted at the back end. In other words, if you shut down the React app and come back again later on and use the app, more than likely all of that client data has been wiped, and you got to start all over again, make your menu selection, etc., etc. Okay, you could store it in the browser local storage, but that's probably not a great idea. So in general, it's not persisted anywhere. It's not persisted across different sessions of the app usage. It is always up to date, though. That's kind of more related to the other type of data now, as we'll talk about in a moment. It's accessed synchronously, so it doesn't typically cause any kind of delay in your app rendering as a result of changing client state data. Okay, the app may need to go through a re-rendering, but it's not. There's not a lag, if you like, between the changing of the state, the client state, and it being reflected in what the user sees. So it's synchronous to that degree. And we'd use the useState hook for storing client state or app data. It's managed from a managed point of view. Well, it's up to you, really. Depends on the nature. If the client state is shared by multiple components, then let's use our context approach. That's fine. If the client state, particular piece of client state data is just only used by one component, then make it private to that component, stored inside in some sort of state variable. So that's straightforward. We know how to do all of that at this stage. The other type of data that a React app or any single page app needs to be aware of is what I'm calling server state. And server state is that data that the client gets from the back end. So in the context of our movies app, the list of Discover movies would be classified as server state data. The details on a particular movie, my list of friends, all of that. The characteristics of server state data is that it's definitely persisted, and it's persisted remotely. It's persisted at the back end. It's shared by all instances of your client, and it's accessed asynchronously because we're retrieving it across a network, so it has to be asynchronous. And because of that fact, I'm saying it impacts on the user's experience, because the app needs to wait for the data to arrive. Okay, it displays some sort of holding message maybe, and then it goes through a re-rendering, but the re-rendering, once the data arrives, might be after a period of time. And we try to minimize that or avoid it if we can. And we'll see in a second how we might be able to avoid it. I'm saying here it can change without the client knowing. So if you've got two instances of a React app running in two different browsers, and one user makes some change to the server state data, in other words, they post some updates to the data, then how can we guarantee that the other client instances are aware of that change? So they may not be, and hence they may be working with stale data or old data. That's a problem, I guess. And we use the use state and the use effect hooks to implement accessing, retrieving, and storing server state, which we know about. Now, in terms of managing server state data, I'm saying there's a couple of options available to us. We could spread the server state data across multiple components. That's nice, I'm saying, from a separation of concerns point of view. The downside of it, though, is that, so if I've got a number of pieces of server state and those pieces are being managed by different components in my component hierarchy, what it actually means is that every time one of those components remounts, then that component is going to re-request that data from the backend all over again, unless we do something about that. At the moment, that is what's happening. So there's a lot of unnecessary refetching of server state data going on when you break up your server state across multiple components. Alternatively, we could put all of the server state into one context. And that means, by the way, what I didn't say at the time about context and the provider context component, because the provider context component tends to be very high up in the component hierarchy, then typically that only mounts onto the virtual DOM once, and it's never unmounted. So that's good in the context of data fetching. That means the first time your provider component mounts onto the DOM, it requests the data from the server and stores it in the context, but it never requests it again during the session. Okay, so that's good. Obviously, we're not refetching data unnecessarily. Okay, the data could become out of date, but we're not doing unnecessary retrieval of that data. Excuse me. So the advantage of putting all of your server state into one component as opposed to multiple components is you're not doing any unnecessary fetching of data. Before the downside of it is you're potentially fetching all of the server state data, even though some of it may not be required yet. You know, some of the server state data may be required by a particular page or set of pages in the app, but the user hasn't actually navigated to those pages yet. So why delay the initial load time of your app by retrieving certain server state data when it's not actually required yet? So that's the downside of taking the global approach. There are many third-party libraries that manage server state data for us. You may have heard of some of them. Redux is one of them, probably the most popular one. But Redux is essentially the same as option 2 above, as I'm saying. And ideally, I'm saying we want the best of option 1 mixed with the best of option 2. The best of option 1 is good separation of concerns, not retrieving data until it's actually needed. The good part of option 2 is you're doing no unnecessary refetching of server state. To demonstrate this, I have a very simple, I've taken my kind of filtered friends and I've adapted it to a movies, very basic movies app. So in this simple app, I've got 2 pages. One page, as you can see, lists 20 movies from the Discovery API. Okay, there's filtering going on, but that's not really important. And if the user clicks on one of these, then we go to the movies detail page. Now, because I'm not really interested in how the data actually looks, I'm just rendering the movies object that comes back as just a JSON structure. Both of these pages make a request to the backend. Okay, so they both have a HTTP fetch request as part of their logic. Right. what I'm showing you here now is the problem with the app. And you know, you would be able to, if I go back, you would be able to implement this no problem at the moment. We know exactly how to do it. We'd have a use state and use effect hook associated with this page, and we'd have a use state and use effect hook associated with this page. So that's fine. The problem though is what's actually happening in the background. And maybe if I demonstrate it. So the code now for this is the archive with this week's set of notes. So it's this archive here. Usual story, download it, grab it, and unzip it, and run npm install on it. And I happen to have it here, so it's already in my VS Code. And if I just do npm start, do I want that there? Sorry, no, just 1 sec. Just wondering now, do I need to do a little bit of, I'm just talking to myself now, sorry. Yeah, no, it's okay. Do a manual refresh. Yeah. Sorry now. I'll do a manual refresh again. So just ignore the bottom here. I'm not sure why that's appearing. It shouldn't at this stage, but I'm opening up my developer tools, and as well, make sure you select the network tab. If it doesn't appear here, then just select this drop-down menu and you'll find it here. And so what the network tab in the developer tools, as you may know, what it allows us to do is monitor what's happening in terms of network communication between my browser and whatever backend I'm communicating with. And right now, all I'm interested in is just what fetch requests my app is making. So I've selected this one here. Okay, so if I go to the home page and I do a manual refresh, what this is telling me over here is that my home page has made a request to TMDB. And if I kind of click on it, you can see here, right, it's actually making a request to the discovery endpoint. So, you know, you're kind of familiar with that, all right? But it has made a request, and so it's asynchronous, and eventually the data came back and it rendered it. That's fine. Now I'm going to click on one of my movies, and we need to watch what's happening over here. I'll click on the first movie. My app has made another request to TMDB, and you can predict what the request is. It's making a request to the movies endpoint, looking for the details on a particular movie. And so I'm getting my movie details. That's fine. Now, if I go back to the home page, it's requesting the discovery list of movies all over again. And that's unnecessary because I've just gotten them up here. But that's the flaw in my app at the moment. And that is a flaw in the movies app that we've implemented so far. And this keeps going on. If I select the same movie again to get its details, it's requested it all over again. Go back to the home page, yet another request, go back to the same first movie, and it keeps on going. So can we avoid that unnecessary refetching of data? Back to my slides. And that's kind of what I'm illustrating here. Okay, I'm showing you the problem that is going on in the background. And so to solve that problem of unnecessary refetching, we implement, or the solution is to take a caching approach. And I'm sure you've heard of caching before at some stage in some of your undergraduate studies or postgraduate studies. And what is a cache? A cache is, I'm saying it's a temporary storage of data. In our case, we want our browser to perform caching. So we want to temporarily store data somewhere in the browser. And in our case, we want to store the API data in the browser, so we don't have to keep re-requesting it. And by doing that, I'm saying we're reducing the workload on the server, because if you've got thousands of clients talking to the same backend and they're all requesting the same data over and over again, that puts a heavy workload on the backend. So to have caching somehow minimize the amount of communication with the backend, then we're reducing the workload on the server side. But we're also speeding up the rendering process within the browser, because now with the availability of a cache, when our React app requires data that has already been retrieved from the backend, it will be local to it. And so the re-rendering of the particular page will be much quicker, obviously. So it's a better user experience. Just in case you're not familiar with the notion of caching, so where I'm using it here now is I've got my React app, which is my single page app, and I've got a cache, which is my data store. Both of these now, in our case, are running in the browser, and I've got my backend. So the way it works is the user interacts with the app, and the particular page that's loaded into the browser, it requires some data from the backend. So it simply asks the cache, do you have the particular piece of data? So maybe it might be the first 20 movies from the Discovery API. The cache will check to see whether it has that data or not. And if it doesn't, it will request it. Eventually that response will come back. Now though, the cache is going to store it locally here, and then it'll hand it back to my single page app, and that'll go through its re-rendering process. A little bit later on in the same user session, the user navigates back to the same page. The app is still going to ask the cache, do you have the particular piece of data that I'm looking for? But in this case, it will have it. So it'll just return it straight away. So we're eliminating the communication with the backend, and we're getting a much quicker re-rendering happening here. In terms of terminology and caching, a cache, really all a cache is an in-memory data store. The in-memory is in the browser's memory at this in this particular usage of a caching. As you may know, caching is a solution not just in relation to browsers, but it can be used in other contexts as well. But in general, it's an in-memory data store, and anything that's in memory is going to be much quicker than something that's communicated with across a network. I'm saying that from a structural point of view, all a cache is a key value data store. Okay, that's fine. So it's kind of a map structure, if you like. The keys must be unique. That makes sense. The values can be of any type. They can be primitives, they can be arrays, they can be objects. As long as the value is serializable, then it's acceptable as a value within your key value store. So one value in the case of our Movies app might be an array of movies from the Discovery endpoint. Another value might be the details of a particular movie. Another value might be a movie review, and so on. There's this term cache hit and cache miss. If I go back to the previous slide, what we say happens here is a cache miss. A cache miss means that when the client asks the cache, does it have a particular piece of data, and it'll ask it in terms of, does it have a particular key within its key value store? If it does not, then what we say is that a cache miss occurs. Whereas here, when the client asks the cache for a particular piece of data, it realizes it does have that piece of data because it does have the key in its key value store. Then what we say happens here is a cache hit occurs. So that's just terminology: cache hit and cache miss. When you're communicating with a cache, and we will actually be communicating with a cache using hooks, but in more general terms, a cache's interface is very straightforward, really. It has a very limited number of types of requests that might be made of it. So, and I'm just sort of expressing them here in very general terms. Typically, a cache has some sort of get operation where you're specifying a key and you're asking the cache, does it have that key? And it's going to return the value associated with it. Another typical operation might be, you might ask the cache to delete a particular entry in its key value store because you know it to be out of date or stale. Or you might actually ask the cache to completely purge all of its data. And that's as much as you need to, in terms of interacting with a cache, that's as much as you would need to do. Or that's as much as a cache would need to make available as its interface to its client. The client in our case is the React app. Now, over time, you know, the entries in a cache are going to build up, and you know, we don't have an infinite amount of memory available to us typically. So it's probably, it's not probably, it's always the case where when you configure a cache data store, you need to configure a time to live for the entries in that cache. And the cache itself will manage the cache entries. In other words, once a cache entry's time to live expires, then the cache will automatically delete that entry from its key value store. You don't have to do it explicitly. So this notion of time to live and configuring, depending on the nature of the cache, configuring the time to live can be an important consideration, because if you make the time to live too short, then that means that the cache is going to be re-requesting the data more often than it should be from the back end. If the time to live is too long, then the cache is just growing too much. So it's a balance. Now, to bring this all back to React, there's a third-party library called the React Query library, and essentially what it implements is caching in the browser for us, specifically for React apps. So it's a third-party JavaScript library specifically for React, although there are implementations of this caching solution for other single-page app frameworks as well, as it turns out. But it originated as a solution for the React environment. And as do lots of modern third-party React libraries, the way we use it is just through hooks. So instead of those listed, there were sort of interfaces that I was talking about in the previous slide, there are nice convenient hooks available to us. And so here's the most common hook that you would use. So there's a hook called the use query hook, and that hook takes two arguments. The first is the key that you are essentially asking the cache, does it have this key within its key value store? And if it doesn't, then obviously the caching technology, React Query in this case, it doesn't know anything about your backend API. So the second argument here is a function that you have to implement as developer, and that function takes care of communicating with your backend service to grab the necessary data. And we've implemented that functionality already for talking to TMDB. So this has to be the function, and the React Query library will simply invoke this function in order to get the data from the backend. And once the response comes back from the API, from the web API, it will store that data in its key value store. The value will be whatever was returned in the response. The key will be whatever key you provided it here. Of course, if the data is already in the key value store, then what the React Query library does is it grabs the data from the store and just returns it back to the client. Now, look here at what it actually returns, though. It returns a large object because really this hook needs to take care of all possible scenarios, i.e. a cache hit occurs, a cache miss occurs, or maybe the web API returned an error, needs to deal with that case, or the case where the API is slow to come back with the response. So the use query hook needs to tell the React component that's making the request, I'm still waiting for the response. So all of these are actually being communicated by within this object structure that's returned by the use query hook. And all I'm doing here is just destructing. So I'm itemizing exactly what each of these parts of the object that's returned. The data part, well, it'll either be null or it'll actually have a reference to the data associated with the key. The error is obviously going to have an error response that was returned by the API if there was one, otherwise error would be null. Is loading is going to be a Boolean and it's going to be true if the React query is still waiting for the API to respond back. Is error is a Boolean and it's going to be true if the API happened to return an error response. So we will be examining, we'll be looking at these within our component code to determine what the component should do. Should the component just display some sort of a waiting for data message, which it would, for example, if this is loading is still true, or maybe the component displays some sort of user-friendly error message if this happens to have a value, or this happens to be true, and so on and so forth. Internally, if you looked inside the code for this use query hook, what it's actually going to be using is the use state and use effect hooks provided by React. So it turns out that when we start using this caching library, we're going to be replacing use state and use effect hooks within our component code with this use query hook instead. So we'll have physically less code appearing in our components, which is kind of a byproduct of using caching, because you're kind of delegating now, you're delegating the management of the API or the server state data. You're delegating it to this third-party library, which means we no longer have to worry about it. Okay. The only thing is from a developer point of view, if I go back to the previous slide, obviously you are going to have to write this function, which I've already talked about. The other thing you as a developer have to do is decide what are going to be the keys within your cache key value store. And by the way, now the nature of the data inside in your key value store, it'll be different types of data. You know, one entry in the key value store, if we talk about it in the context of our movies app, one entry in the key value store might be a list of movies from the discovery endpoint. Another entry, the value in it might be a list of movies from the upcoming movies endpoint. Another entry might be a movie review. Another entry might be just the details about a particular movie. So the values, their structure will be different, but that's normal for a cache. We don't have a cache for a particular type of data value. A cache tends to hold different types of values, okay, coming from typically one backend, although it doesn't have to be. We might be communicating with a number of web APIs. But you as the developer, you are going to have to decide what are going to be the structures of the keys in that key value store. You have control over that because the keys will mean something to you as the developer. And from the React query third-party library point of view, the query key can be anything. It can be a simple string, or it could actually be something a little bit more complex, like an array, where it could be an array of strings. Maybe some of those strings are actually variables, or it could be an object structure. So it's very flexible in terms of how you decide on the structure of the various keys in your cache. And so by way of example, and this comes from the movies app, obviously. So this looks like a query, excuse me. I'm using the use query hook, but here's, and it looks like the value that's going to be in this particular entry is going to be the details about a particular movie. So I've decided that I want my key to be a serialized version of this here. So the key is going to be prefixed with the string movie, and the value is going to be an actual movie ID. So if I was able to look inside the entries in my cache, and I had over time displayed the movie details page for a number of movies, then I would have a number of entries in my cache where the key would begin with the text movie followed by a movie ID. And I've just decided that's the structure that I want to have for the keys in my cache, where those keys correspond to the details about a particular movie. Now, we're going to have to tell somehow or indicate somehow to this function that this is the structure of the key, because this is the function that's going to have to make the API call. And all this function is interested in is this part here. Doesn't care about the prefix that's specific to the key within the cache. So the function just needs to know what's the movie ID. So if we looked at the detail of this function, we need to, its signature needs to be able to extract this value from within this overall structure. And that's what I'm doing down here. So the function, its signature has to be a single argument signature, where that argument is actually, you can think of it as it's actually pointing at this structure here. And all I'm doing here then is I'm just performing destructuring. So I'm going args dot query key. Sorry, now I'm slightly misleading you. Sorry, slightly misleading. So args, the args argument that will actually be instantiated by the React query library itself, and it's going to be an object, and within that object it will have this information. So I'm showing you here how to actually dig into the object. If you go args.query key, that entire expression is actually evaluating to this structure here. And I'm just doing some destructuring of it. I'm saying I don't care about the first part, because the first part is just going to be the string movie. I am interested in the second part though. The second part is going to map to this object here. And I'm doing some further destructuring here in order to get at the movie ID part. Now I have the movie ID 1234 in the case of the example. And then I do my HTTP GET request to TMDB using 1234 as my movie ID. So all I'm getting across here now is how you access this from within the function, the query function as it's called. And you'll see that being used in this week's lab. The React query library comes with a really useful dev tools plugin. And what the dev tools plugin allows you to do is to see what's actually happening inside in the cache. And that's what this screenshot shows. Now, if I go back to my sample app, so the sample app isn't using caching at the moment. And in order to get it to use caching, and I explain it in the README file, I explain the changes that you have to make to the code. And it's really just a straightforward cut and paste. So I'll just do one of them, and you can read through the README yourself. So it's telling me here, go to the source pages homepage file, which is here. And the README tells you to replace all of this code. I'll just comment it out for now and replace it with, sorry, I just want to kill that there. I also want to kill that. Back to my README. Replace it with this. Okay, let's just see. So that's my key is simple in this case. So this is the home page. So this is where we're making the, we're asking TMDB for a list of 20 movies. Here's the function, and that's going to do the actual communication with TMDB if I need it. And that's very like the function that you've seen from the labs. If I quickly, where do I have it? It's boom, boom. Where do I import that from? API. Oh yeah, it's in here. Okay, there's my Git movies. So that's almost very similar to what we have in the labs at the moment. And okay, here's the structure that use query returns, which I've kind of talked about a little bit there a while ago. So I'm doing some basic boilerplate stuff. I'm checking to see, are we still waiting for the TMDB to come back with the response? If we are, then display some sort of waiting message to the user. Was there an error response? If there was, then maybe display the error message, which wouldn't be great from a user experience point of view, but just for illustration purposes. If neither of these are the case, okay, if neither of these are the case, then it's going to start actually accessing the data that comes back, or the data that has been already in the cache. We can't really tell. It's either in the cache already, or it has just been retrieved from TMDB, and we're just indexing into it because we know what the structure of that response that comes back from the discovery endpoint is. And we've got the normal kind of, that's the filtering stuff which I don't talk about. Sorry, this is the filtering stuff. This is just the event handler for the search box, which isn't interesting. And then we just display the stuff. So having made that one change now, so now my home page is using the cache. And so if I save that change, assuming I haven't made any typos, go back to my app and see, has it improved things for me? Do I have an error? I don't think there is. Just do a manual refresh. Hopefully it'll be okay. Wouldn't you know? Something silly now. Oh, sorry, I see what I've done. I need to, yeah, I need to leave that enabled. Okay. Still not happy. What have I done? Okay. Now, so I do have caching happening in this page. I don't have caching on the other page though, but let's see what's happening from a networking point of view. And I'll just do a manual refresh to go from scratch. So I'm still making the initial request for on the initial loading of the home page to TMDB. That makes sense, or at least the query cache library is doing it for me. When I go to a detail page, that makes sense. But now when I go back to the home page, I should not see a re-request to the Discover endpoint. So if I click on the home page, and there isn't, it's not making the request a second time because it now has the data in the cache. Still though, I have the problem of, if I go back to the same detail page, it's going to be requested, but every time, at least when I go back to the home page, it's not doing it. And so in the README, I explain what changes you need to make to the movie's detail page in order to get caching working on that one as well. And you can follow the README to see that for yourselves. Oh yeah, the developer tools, which I've opened down here now. And because I'm only using caching and the home page, the only entry that I'm going to see in my cache is the one related to the discovery endpoint. And if you looked at my code, I said I'm going to have the key of just the string discover. And lo and behold, there is an entry in my cache. That's what I'm looking at down here. The key is the string discover. And if I click on it, and if there are other ones, if you click on it, then what it'll show you over, maybe if I just pull that across, I'm going to do a manual refresh again. Sorry about this now. But I'm going to close off the developer tools. What you see over here then is some detailed information. In particular, you can see the value associated with that key, because if I drill down here, here is showing me the data and the results, and there are my 20 movies there. Now, if I had implemented caching on the details page, movie details page as well, then you would see entries like this appearing in my cache. And this corresponds to what I've chosen to be the structure of the keys associated with movie detail entries in my cache. I think it's a sensible key. The key should really make sense from a readability point of view, and that key makes sense to me anyway. And if I had retrieved details about other movies, then you would have multiple entries like this appearing down here, but of course they're all going to have a different movie ID. And it's the same thing. You can click on them and you can, so what the developer tools allows you to do is to kind of monitor what's happening in the cache. Obviously, it's only something you would be doing during development phase. So that's what I'm saying up here. It allows you to observe what's happening in the cache. Also, the developer tools that comes with the React query allows you to actually manipulate the cache. So you can, for example, and these are the kind of manipulations that you typically might want to do. So clicking on any one of these things carries out a certain operation on the cache itself. For example, if you hit the refresh button, and you would hit the refresh button associated with, you'd first of all select a particular entry in the cache, and then you would click one of these buttons. So if you click the refresh button, then what that I'm saying here, what it does, it actually forces the cache to immediately re-request that data from the web API for whatever reason that you might want to do that, because you know it changes frequently or whatever. Invalidate, if you click the invalidate, what that is going to do is it marks that entry as being stale. And once an entry is stale, so what am I saying here? It sets the entry as stale, and then the cache will request and it'll re-request that data from the web API, but only as soon as a component actually needs it. By the way, as well, the kind of color coding over here and the numbers over here, that tells you something about the nature, about the current kind of status of that cache entry. So if it's backlit in green, now there happens to be only one backlit in green, but if it's backlit in green over here, that tells you that entry is currently being used by a component that is mounted currently on the DOM. If it's got this other kind of purpley dark purple background, that tells you it's not associated with any component that's currently mounted on the DOM. And the number tells you how many components are referencing it, if you like, or are using it. So it can be very useful, mainly if you're concerned with improving the performance of your cache and making sure that your cache is refreshing entries in it because the backend API data is being updated. And you kind of have to estimate the frequency of update of the data at the back end, and that really depends on the nature of the application and the nature of the usage of the application. I'm not going to get into that. So that's caching, and spend a little bit of time playing around with it. I think it might be worth your while. I'm not going to talk over that. It's just summarizing everything that we've just been talking about. So this is the last thing that I want to cover. I'm kind of checking my watch. I thought I was out of time there for a second, but let's cover this topic because I won't be back from next week on or from this week on. So if I don't cover it now, it never gets covered. And so this is the last topic, oddly enough, and it's a bizarre kind of topic to finish with. And it relates to good old authentication and log in and logging out, and how we can implement that in a nice way in the context of a React app. And so it's all about nominating certain routes within your routing configuration as being protected or private, i.e. a user has to first of all authenticate with the app before they can access particular routes. So that might be before they can navigate to the favorites page. Maybe we want to force them to authenticate, or even before a user can actually nominate a movie as being one of their favorites. You know, when they can't click on the heart icon in the home page unless, or if they do, they first of all have to authenticate before they can do that. So these are the kind of typical everyday React app authentication and authorization that we'd like to be able to implement. And this relates to one of the last sample in my list of samples. So it goes back to this make-believe email client, if you like. And so I've got my navigation links in my app header. And I think I might have mentioned to you that, oh no, sorry, I haven't. So the idea is that these two pages here are going to be accessible to anybody. But if the user tries to click on these hyperlinks here to bring them to the inbox page or the profile page, then they must authenticate. And so if a user clicks, let's say, on the inbox link, then they're automatically, as well, on top of every page, we've got some indication as to whether a user is currently logged in or not. Again, fairly typical feature. But if you click on the inbox and you're not logged in, then you're automatically taken to the login page. You have your username and password, which I don't necessarily need to worry about in this illustration. You click login, that checks with the backend to see is it a valid username password combination. And then it actually takes you to the page that you wanted to go to in the first place, assuming you're authenticated. Okay. Now, across all the pages of my app, I've got some sort of indicator that the person is signed in. is logged in, sorry, and there's a sign out button. And if you click the sign out button, you're taken to the home page. Fairly standard kind of stuff. The idea of knowing whether somebody is logged in or not, that might be something that multiple pages in my app need to know about. And hint, hint, maybe we're going to need to use a context to store whether there is somebody logged in or not, and perhaps store their username so that their username could appear at the top of every page. Now, as well, what we're seeing here is that we want certain routes within our routing configuration to be protected. In the case of the previous slide, I wanted the inbox route to be protected, and I also wanted the profile route to be protected. But the React Router library doesn't provide any solution for us, unfortunately. We have to implement a custom solution. But if you browse the web, you get lots of ones, although one particular solution has kind of emerged as being the best approach towards it for the React Router library anyway. So we have to write our own custom one. And obviously we'd like the custom one to be compliant with the whole nature of React and how React does things. So we're going to be using components. We're going to use the event model. We're going to use the kind of re-rendering and all of that aspect of React as part of our solution. We can't avoid it. From a routing configuration point of view, this is how we'd like it to look. So that it's nice and declarative and very obvious to anybody reading our code that certain routes within our routing configuration are private. So you can see here, I've got a component called private route, and that tells me straight away, well, this must be protected in some way by requiring the user to authenticate. Similarly for this one. But of course, there is no component called private route. We must implement it. And overall, I'd like my solution to have these qualities or these features. I'm going to use a React context to store the user's credentials once they have logged in, because as I said a moment ago, a number of pages will need to know whether somebody is logged in or not, and they may need to know exactly who is logged in, what's their ID or their username, because they may use that to make API calls or just display some sort of welcome message for that particular user. There's going to be a lot of programmatic navigation that I need to have, because I said there a while back that when the user is forced to log in, we'd like to, well, forcing them to log in means we need to redirect them to the login page. So we need to implement that programmatically. And also, once they have logged in successfully, we need to redirect the app back to the actual page they wanted to go to. And that's another example of programmatic navigation. The third feature is something that we're all used to. And it's a nice feature, and it's what I'm calling this remember me feature. It's really what I was talking about there a moment ago, that when a user tries to access a protected route, but they're forced to log in, once they have logged in, we'd like the app to somehow remember where did they want to go to before we force them to log in. The simple thing would be to always send them back to the home page after they've logged in successfully, and then require them to manually go to the actual protected route that they wanted to go to. But now they will be able to access it because they've already authenticated. But forcing them back to the home page and getting them to navigate manually to wherever they wanted to go is not a nice user experience. So we'd like the app to somehow take care of that for the user. And so the remaining slides, I'm going to show you the different parts of the jigsaw that will achieve what we're trying to achieve. So the first part of the jigsaw is we're going to have a context and a provider component that is solely responsible for dealing with authentication. So here I go. I create my context, my orange box, if you like. Here's my provider component. And from a state and data point of view, what it's managing is just who is currently logged in. Now I'm storing username and password here. Probably password isn't a great idea to be storing that, but just ignore that if you like. I certainly should store the user's username here. I'm initializing to null, obviously, because nobody is authenticated initially. And then I've got a mixture of convenient functions and necessary functions within this context provider component. I've got a function called authenticate. So presumably the login page is going to be calling this function whenever the user fills in the login form. And okay, there'll be some logic in here, maybe communicating with the backend, checking to see does the username password combination okay. And if it is, then I change my state with that user's details. Of course, changing the state means that this component is going to re-render and all of its subordinates are going to re-render, but that's just the nature of the way React works. This is just a convenience little constant that I'm declaring for myself here is authenticated. So that's going to return either a Boolean true or false, depending on whether user.username is equal to null or not. So that constant might be useful to make available to lots of other components, because many other components may need to check, is there somebody currently logged in or not? Do one thing if they are, do something else if they're not. So, but we probably need to put this into the context that I've created up here so that other components can access it. I've also got a sign out function, which does what you might think it does. And here's where I'm putting entries into the context. So I'm sharing the is authenticated. I'm sharing the authenticate function and the sign out function. I could share the username as well here if I want to do the state variable up here. That probably would be a sensible thing maybe, but I just didn't need to use it in the example, but I guess it would be sensible to have it in here as well. So that's the context provider. And as before that. So we have this, we want to have this, this private root component as part of my routing configuration, but I've got to implement that. And that's what I'm showing you down here. And if we kind of step our way through it. So this is a consumer of the auth context from the previous slide. So I'm using the use context in order to allow me to access the values exposed by that context. What I'm doing here is, this is a hook provided by the React Router library. And just to give you a little bit of background, every time the URL in a browser's address bar changes, what the React Router library does is it creates an object called the location object. And I'm showing you what the structure of that object is over here. Now, the only part of that object that we're interested in is the path name part. And so path name will contain the new path that the browser's URL address bar has changed to. So for example, when the user clicks the inbox hyperlink in my navigation headers at the top, let's say that causes the browser's URL address to change to localhost 3000/inbox, and it's the /inbox that we're interested in. Now we can get at that path value by using the use location hook, and that will be useful to us, because that is going to allow us to remember where the user wanted to go to before potentially we force them to log in. So I'm just using normal destructuring here, and I'm accessing the path name from this object over here. Could be anything, could be /profile, /inbox, /whatever. What I'm doing here is I am taking the various props that are being passed into this component, because here's the implementation of the component, and I'm doing some destructuring on them. In particular, I'm interested in what is the component that we really want to have mounted onto the DOM if the user navigates to this path. So I'm grabbing the component from the props, And I'm just renaming it to component with a capital C just to make my code, the rest of my code, look a little bit better. That's not essential, but that's what I've decided to do. And all of the other props, I'm stuffing them into a local variable called rest. You've seen that pattern before. Here is where the meat of this component is concerned. Here I'm checking now to see, is there somebody currently authenticated or not? And if there is somebody authenticated, then I return a normal route. If there isn't, I return a redirect route. Now, the way you need to interpret what's going on here is that at runtime, if I can go back just a couple of slides, at runtime, what actually happens is these private route entries are replaced dynamically by either a normal route entry or a redirect entry. Every time when my component mounts, or when my app mounts into the, or loads into the browser initially, all of this is evaluated. And so each private route entry here, that's evaluated. And by evaluated, I mean this code executes for each one. And we can now see that what that code returns is either a normal route entry or it returns a redirect entry. So the private routes entries in my routing configuration will be changing to either normal route entries or redirect entries. They'll be changing every time the app goes through a re-rendering process, and they will either change to normal route entries if the user is currently authenticated, or they will change to redirect entries if there is no user currently authenticated, which kind of makes sense, because if there's nobody currently authenticated, then every time a user tries to access one of these paths, we should redirect them to where we're redirecting them to. We're directing them to essentially the login page. If I examine this one here, the redirect says change the URL in the browser to /login, and more than likely there is an entry in my routing configuration which matches the /login path to the mounting of the login page. That's to be expected. What am I doing here? What I'm doing here is I'm passing as an additional prop to the login page the path that the user actually wanted to go to. This value here is taken from up here, and I've kind of explained where that value is going to be, what it's going to be bound to. It's actually going to be bound to whatever path name you up here, and this is the path name where the user really wanted to go to, but we're forcing them to go to the login page, but we're passing to the login page where they wanted to go to. So presumably inside in the login page logic, it will actually be able to access this value here. And if the user's username password combination is okay, then it will do a programmatic navigation to this path, i.e. it's going to send them to where they actually wanted to go to. That's quite tricky coding, but there you go. Of course, if there is somebody currently logged in, then, and the user tries to navigate to one of these protected routes, what they'll actually be navigating to is an ordinary route, because this expression is going to evaluate to true. And so the private route entries in my routing configuration, they'll be replaced with normal route entries. And the setup of this route, the props of the route are taken from whatever this has been bound to, which is going to be up here. And the rest of the props are spread out as well. That's also quite tricky coding, but if you want it, it's just boilerplate. You can cut and paste. It's a generic implementation. It'll work in any app, provided you use this private route to indicate which routes within your routing configuration you're forcing authentication for. This is my login page. Similarly, the login page, if I skip down to here, the login page in terms of what it renders on the screen, it first of all checks, is there somebody authenticated or not? And if there is somebody authenticated, then we redirect them to where they actually wanted to go to. If they're not authenticated, we just display the normal login page. So on the very first rendering of this login page, this is always going to be the case, right? You have to display the login page at least once to allow somebody to log in before you have the other case where there is the login page renders when there is somebody already logged in. So anyway, the login page renders, the user fills out the login username password, which we don't need to in this case. They click on the click handler, or they click on the submit button of the login page. That triggers my little handler up here, and it passes the well, I'm manually just creating a random username, but usually obviously the username would be taken off the little web form associated with the page. And I'm then calling the authenticate method provided by my context. Remember, that's the method where you give it a username and password, and it communicates with whatever authentication process is going to do the validation for us. Now, this method, if you remember from, sorry now about this, from back here, it eventually will, if the username password combination is okay, it will force a state change. And that state change means this component re-renders. And as a result, my login page is going to go through a re-rendering. Now, on this second re-rendering, this expression is going to be true. And what do we do? We redirect them to wherever the user actually wanted to go to in the first place. The from here is being computed up here, and it's a nice little elegant piece of code. I didn't write it. I just grabbed it off a solution on the net. How you interpret this piece of code here, this is just kind of from a JavaScript perspective. When you see an expression like this, what happens is JavaScript evaluates the thing before, this is the R symbol, obviously. It evaluates the expression before the R symbol. If that expression is true, then it assigns that value to whatever's on the left-hand side of the equal. If this value is false, then it assigns what's after the R symbol to the expression, to the value on the left-hand side of the equals. And to try and break that down, what I'm doing up here is I'm using this use location hook again. Now, I suppose the easiest thing for me to say is that this expression here, what it's going to do is it's trying to access what was passed here. And in my case, that means it's trying to access the path /inbox. So that's what's going on here. I'm trying to access the path that the user wanted to get at. And I'm accessing it via the state variable that was passed here. Sorry, here. So state equal to, this is just normal destructing. I'm extracting the from key from this object here. Sorry now for jumping around, but the state object looks like this. State object looks like this here. And it does have a key called from, and its value is a path name string. So if I'm doing destructing, that means that this variable here from is going to have the string corresponding to the path, which would be, for example, /inbox. So the question you might ask is, well, what's this all about? You see, there are two scenarios when the login page might actually be displayed onto the screen. One is when the user tries to access a protected route. The other, of course, is if the user clicks the login button in the home page itself. And if I go right back to the beginning, I have a login button here. Like, what if the user clicks that login button directly rather than clicking one of these protected routes? Where do we redirect them to then? Where do we send them to? Well, an obvious default would be just send them back to the home page, because they haven't really given us any indication of where they want to go to. And so that's what is being handled by this. That's what's being handled by this here. I'm essentially kind of artificially creating an object that is similar in structure to this object down here. And I'm setting the path name to /. I think I've said twice already, I'll say a third time. The implementation is actually quite tricky. I don't deny that. It is boilerplate though. It'll work for any app that you write, which is kind of nice. It's reusable. It would be worthwhile though, just spending a little bit of time understanding the flow of it. And by that, I simply mean sticking a few console.logs so that you can get a sense of, for example, what use location returns for different use cases, and do examine it in the context of this little simple mini app that I'm giving you. Right. Of course, just to be sure, the sample that I've just stepped through there is sample 9. So we have the auth context, which I talked a little bit through. The app header, that's just the list of navigation links at the top of each page. And then the login page and the index.js, I think, has all of the other pages, like the home page, the public page, and I think maybe the profile page as well. Is that right? What does pages contain? No, it looks like that has the various pages. Some of the pages anyway, the public and the profile page. The index just has the routing configuration, yeah, and the home page, I think. No, just the routing configuration. Right, but you definitely need to play around with that, and you need to play around as well with the caching sample as well, just to be comfortable with how you use the React query library. You don't need to worry too much about managing the cache. In fact, you don't need to worry at all about managing cache or deciding on time to live values or any of that kind of stuff. Okay, where are we time-wise? Close enough. So I am going to leave it at that for today. Just display my camera. So that's it, guys. Heavy enough going, I admit. Even the use case there is tough going. You need to play around with that. So you can do that in your own time. Of course, you do need to complete the final lab this week as well. Are there any closing questions for me, I wonder?
The last part, authentication, that to be implemented in that movie app?
Yeah, it was part of the spec. So what Frank will actually be doing with you is he will be implementing the back end of authentication for you. So you'll be storing username, passwords, and tokens and all of that. You'll be storing that, handling that in the web API. And you can literally take the code from my sample line there and lift that and put it into your Movies app. Okay, you have to flesh out the login page so that there is actually username, text, there's actually a form there that the user can enter username and password. But other than that, if I go back and share my screen again, I can appreciate now if you're thinking, gosh, that looks a bit tricky to me, but it will gel with you, I think. Let me just go back to, in order to stitch it into the Movies app, you will just simply put in these private routes in your routing configuration for whichever parts of your app you want to have private or protected. You will have to use, you can literally take the implementation of private route that I've given you, which is, just give me a second now. Well, you've seen it from the screenshots you'll use the auth context, almost identical. The only thing that's going to change in the auth context is, am I looking at the auth context? Is here. You're going to have, sorry now. In here, you'll probably be talking to your web API where you'll be passing it the username and password and get the web API to authenticate. And if it comes back successfully, then you'll be changing the state variable. So you'll use the useState useEffect hooks or the useEffect hook to do that coding for you. The rest is as before. I don't think you need to change hardly any of this. Okay, the sign out you'll have to change. Okay, because I'm just mimicking a sign out there. I'm just using set timeout to indicate that it's a kind of a delayed execution, but you may have another useEffect hook here, perhaps. Well, you can't put, I said you have a useEffect hook here. You can't put a useEffect hook inside a function. You have the useEffect hook at this level here, but you'll use the dependency array to control when it actually executes. You'll have a useEffect hook possibly as well to take care of signing out. So you may need another state variable to indicate when the user has clicked the sign out to trigger that useEffect hook. The private route implementation, I don't think that changes at all. You can literally lift that and use it as it is. So the auth context, the private route implementation, you can take those as is. The login page, you can take as is. The only thing you're going to need to add is just a simple little web form down here. And then, hook it up to the web API backend that Frank will be providing you with. But having said all of that, I would not start dealing with authentication at this early stage of your React development. I would just do your React development, whatever features you're going to have in your expansion of the Movies app, and bring in authentication at the latter end of your React development. That's what I would recommend.
Okay, got it.
Yeah, and see how you get on. And maybe initially just bring in the authentication where you're not actually communicating with the backend, and then try and get it integrating with your backend. When initially you won't have it communicating with the backend at all, and so you can just have a blank web login form, and the user just clicks the login button, and that should make the protected route available to the user. So they won't really be entering a username and password at all. Once you get that working, now you know that from the React point of view, your authentication is working as you expect it to work. In other words, it's protecting the particular route. It's forcing the user to go to the login page for particular routes. If that's working, then you start cooking it up to your web API. Of course, if you want to have authentication, not at the route level, but at the kind of feature level, what I mean by that is, supposing in the home page where we display our cards, and down at the bottom left-hand corner of each card, there's a heart icon that the user can click on. Now, what would be really nice is when the user is not logged in, maybe that heart doesn't appear at all, but when the user is logged in, the heart does appear. And that can simply be controlled by, if you think about it, you can control that by talking to the auth context and just checking to see, is there somebody authenticated or not? Does that return a Boolean true or false? If it returns a true, then include the heart in what's displayed on the screen. If it's false, then don't display it at all. So it's as simple as that, really. If you want to control particular features from public access. Does that make sense?
Yeah, I got it.
Yeah, you definitely need to look at it. I don't deny that the code is tricky, which is why I covered it at the very end, even though it may seem like a trivial feature. The code is by no means straightforward. So don't let that stop you from playing with it. Right. Okay, folks. I will take this week's lab, and then it'll be Frank from here on in. So we'll leave it at that. Bye for now.
Okay, thank you.
Thank you.
Thanks, David.
So I have a quick question. Sorry to ask, I forgot to ask.
Sure, yeah.
So are we going to use this TMDB API for going on for the assessment assignments?
Have you seen the specification?
Yeah. So
Yeah.
I was thinking whether we are going to manually change that after the Frank's class. No, right?
What? No.
The
I'm not sure
APIs.
what you mean by that now, though.
Okay, we will still be using that TMDB API, right?
You will be.
Okay.
In fact, I think what Frank is proposing to do is to develop a web API, but he will just be proxying any communication with TMDB. So the way you might envisage it is your React app will be talking to the web API that Frank will develop.
Okay.
Frank's web API will simply take any requests that your React app makes for movie-related stuff. It'll just take that request and pass it on to TMDB. In other words, proxy it. The response that comes back, it'll just take the response from TMDB and send it back to the React app. So it'll have very little to do.
Okay, so the signature will be same, right? The API.
Yeah.
Okay.
The only thing that the web API might be doing in relation to movies is, up to now, we're storing our favorites in an array in the browser.
Yeah.
Obviously,
it might be in DB,
that's
right?
going to be stored in the database.
Okay.
Yeah.
Okay, so pretty much we can start the UI and all, right?
I think you can definitely get into the UI side of it now. Yeah.
Okay.
Definitely.
Okay.
That is the intention, really.
Okay, that's cool.
And any kind of new data, like your fantasy movie, for example, all of that will be stored in the browser at the moment. Ultimately, stored back in the API, though.
Okay, got that. Okay, thank you.
That's good. And if you've got other questions in relation to the assignment, just contact me.
I'll put in Slack.
Contact me on Slack.
Okay, thank you. Take care. Bye.
All right, bye-bye.
Thank you so much.
Any other questions? No.